Hi, I just want to wrap up the evolution of the atomic theory. I just want to go through it real quick just to make sure we don't have any loose ends. The first guy we're going to talk about is Dalton. In the early 1800s, he came up with just the theory of the atom. He looked at other people's work and came up with this theory based upon what they were seeing. In the late 1890s, J.J. Thomson, that was about 100 years after Dalton, he did the cathode ray tube experiment, which actually a beam of particles was going across, a magnet bent the beam, and by the fact that a magnet could bend the beam, it proved that there was positive and negative particles. Okay, so his picture came to be, a lot of people call it the plum pudding model, but I call it the chocolate chip cookie model. So the little pluses there are the chocolate chips, and the minuses there are the cookie dough. So that's how they viewed pluses and minuses, just kind of all together mushed in the same space. About 10 or 15 years later, Rutherford did his famous gold foil experiment. That's where he shot alpha particles through a really thin foil of gold, and what he found out, to his surprise, is that most of the particles went straight through. That proved to him that all of the atom there was made up, most of the atom was made up of space. So it proved that there was a positive center and negative electrons on the outside. Almost the same year, very shortly after, a guy named Bohr, he was actually a big mathematician as well. He looked at the hydrogen spectrum, the color spectrum for hydrogen. What happened was he found very discrete lines. That to him proved that electrons held very specific energy levels. So he was the guy who proved energy levels. His picture came to look like a positive center with orbits like planets orbit the sun. His electrons orbited in circular paths. He was almost right, but not quite. Before I go into the current model, I just want to summarize the contribution that these guys had to our current model. They all made a large progression to what we know today. It doesn't mean they were wrong. They made very good advances. Dalton, he was the first one to say that there are things called atoms. He was the first one out of the gate to just even mention the concept, so very hugely important. Thomson said that atoms have charge. Okay, again, very hugely important that we know that there's protons and electrons. Rutherford showed us that there was a lot of space between the positive and the negative charge. Bohr showed us that those electrons orbit at very specific energy levels. He thought they orbited like planets, but not so much. Our last model, I don't really so much want you to remember the guys' names, de Broglie and Schrodinger. I really want you to remember quantum mechanical model. That's what we're going to be calling it throughout the year. The big contribution from what they did from Bohr to the quantum mechanical model is that they determined that those electrons really didn't go in circular paths, that the electrons really kind of flew around like little flies in very predictable areas, but sometimes they went off and came back. But really what he came up with was the fact that there are orbitals. An orbital is an area of probability of finding an electron. This quantum mechanical model is the current model that we have today. Again, their major contribution was the fact that we know that electrons are found in orbitals, which is an area that you will probably find an electron. Thanks for wrapping up with me today. Have a good one.